We have been working in class this week on adding and subtracting fractions with different denominators. We have learned when we used our polygon pieces that we cannot add thirds and sixths together. We have to trade in for common pieces. With paper and pencil, this is called finding a common denominator. I'm going to come below my problem. My two denominators are 3 and 6. So I'm going to come below my problem and skip count or use my multiplication tables and find a number that is a multiple of 3 and a multiple of 6. So skip counting by threes, I have 3, 6, 9, 12. When I skip count by sixes, I get 6. There, I can stop. I don't even need to keep going. As soon as I get a number in common on both sides, that is the number I want to use as my new denominator. So I'm going to make both of these fractions now have sixths. I'm trading in my thirds for sixths. Okay? When I look at my 3 and I count over, let's count over. That's 1, 2 numbers to the 6. So that's going to be times 2 times 2. When I go down to the row with 6 and I count over to the number I've circled, I have 1. So that means that the next fraction is going to be times 1 times 1. 3 times 2 is 6. If you change the bottom, you must change the top. So 1 times 2 is 2. Coming to my second fraction, 6 times 1 is 6. So 2 times 1 is 2. My fractions are now 2 sixths plus 2 sixths, which equals 4 sixths. We only work with the numerators. We never, never, never add or subtract the denominators because that already represents our total. We're working with sixths. So this is 2 pieces out of 6 and 2 pieces out of 6. I now have 4 pieces out of the 6 pieces in my set. I'm not working with twelfths. I'm working with sixths. So we're not going to add the 6 plus the 6. Okay, looking at my 4 sixths, I need to run through the checks that we did in class this week and see if this fraction can be put in simplest form. There's not a 1 in the numerator, so that does not match my first check. The fraction 4 sixths is not in counting order. That does not match my second check. I do not count 1, 2, 3, 4 sixths. My third check says both numbers have to be prime. Well, neither 4 nor 6 is prime, so I'm going to build my T-chart and think of all the factors I can for 4 and 6. So starting with 4. I know that 4 times 1 is 4, and 2 times 2 is 4. With 6, I know that 6 times 1 is 6, and I know that 3 times 2 is 6. I now want to look for numbers that are on both sides of the T. I have a 1 on both sides. I have a 2 on both sides. I do not have a 4 on this side. I do not have a 6 on the other side. I do not have another 2 on the 6 side, and I do not have a 3 on the 4 side. So 1 and 2 are the only numbers in common on both sides. I will now look at my circles and pick the number that is the largest digit in the circle, and it's 2. 2 is greater than 1. The partner answers are the answer to simplifying the fraction. 4 sixths actually becomes the fraction 2 thirds. And if I go through my checks again, I do see check number 2, which is counting order. I do count 1, 2, 3. I'm finished.